Hello viewers, welcome back to our YouTube channel 3D Parametric Solid Model Drawings. Today we will create an assembly file of drill machine in Autodesk Inventor. In this video, you will learn the full modeling process of this model and its components. Okay, alright. We have used 16 part files and 4 content center part files to make this assembly. Some pics I am showing you at the beginning of this video. If you want to get the file of this model, I have given the link address in the description of my video. By visiting that link, you can get it easily. Okay, that's it. So let us start the tutorial. First of all, we are going to create a drill machine frame like this. Okay, that's it. Now we will create a new part file from here in Autodesk Inventor. Click OK. Now you can see here my design window is visible here in Autodesk Inventor. Okay, alright. Now we will create a vertical line. Okay. And apply the coincident constraint between the midpoint of this line and center horizontal construction line. Okay, alright. Now we will activate the dimension tool from here. Okay, select this line and its length will keep 0.625 inches. Okay. Now we will activate the offset tool from here. Okay, select this line, click continue. Apply the coincident constraint between this midpoint of the line and center line. Okay. Now we will apply the dimension of this line. It will keep 0.313 inches. Click done. Now we will activate the symmetric constraint from here. Okay, select this line and select this line and select center line. Now see the result. My symmetric constraint will be applied between these two lines. Now we will apply the dimension between these two lines. It will keep 6.874 inches. Okay, that's it. Now zoom all button from here. Now we will create another line over this point. Okay, now see. And apply the dimension over this line. It will keep 1 inches. Now create another line from this point. Okay. And fix the dimension over this line. It will keep 0.15625 inches. I'm sorry, this dimension will keep 0.1565 inches. Okay, now we will create another line on here. Its length value will keep 1.068 inches. Okay, that's it. Now choose the extend command from here. Okay, select this line. Now see. Now we will create another line from here and close the sketch profile. Now we will drag the sketch over this in this position. Okay. Now we will activate the rectangle tool from here and start the rectangle from the end point of this line. Okay. And set the height of the rectangle. It will keep 0.156 inches. Select the width of the rectangle. It will keep 1.0516 inches. Click done. Zoom all the sketch like this. Okay, now my sketch is fully constrained, so we will exit from the sketching environment. Okay, that's it. Now choose isometric view from the view cube. Now we will activate the revolve command from here and select these two sketch regions in the graphics window like this. Now we will choose axis option from here and select the horizontal axis of the part. Now you can see here the revolve feature preview is visible here in the design window. Click OK. Now see, my first revolve feature has been created here in Autodesk Inventor. Okay, now we will save the file with the name drill machine frame in the drill machine folder. Okay, that's it. Now we will create a new sketch over the XY plane. Okay, now we will activate the project cut edges command from here. Now you can see that the entire model edges are created here in the design window. Okay, that's it. Now we will select the slice graphics option in the design window. Now see, you will also activate this command by using F7 key on your keyboard. Okay, alright. Now choose the front view by selecting the view cube. Now we will activate the project geometry command from here and take the project of YZ plane. Now select the entire sketches and we will change the color of the sketch as white. Now we will create a line from this point and its length will keep 0.2136 inches. Now we will create a slant line from this endpoint of the previous line like this. And its dimension will keep 0.43637 inches. Okay, alright. Now we will create two more lines over the opposite side of the revolve feature like this. And afterwards we will apply the dimensions over these lines to fix them. Now we will draw a line between these opposite endpoints of the line on here to connect the sketch. Now draw a line from this point parallel to this line. And fix the dimension 0.27716 inches. Now we will draw another line on here to connect the sketch profile. Okay, that's it. Finish the sketch. Save the part file. open the visibility of the XY plane. Now we will activate the plane command from here and create a new work plane at an offset distance value 0.09375 inches from the XY plane. Now we will change the name of this work plane as a base plane 1. Okay, alright. In the same manner, we will create another new work plane over the opposite side of the revolve feature from the XY plane. Now we will close the visibility of the XY plane. Choose the left view to see the result. Now this plane name will keep as a base plane 2. Okay, alright. Now we will save the part file. Now we will start the Revolve tool from here and select this sketch region in the design window. Now select the center line from the axis for the revolution. Click OK. Now we will select the new solid option in the Revolve dialog box. This option must be selected on here. Otherwise, you will not be able to generate a separate solid body on here and it will merge in previous Revolve feature. Okay, that's it. Click OK to finish the command. Now you can see here my second Revolve feature has been created here. Okay, alright. It looks great. Now go to the solid bodies folder in the browser bar. You can see that the two solid bodies are visible here. Select this one and this one. Okay, alright. Now we will activate the split command from here and choose the trim solid option. In this case, at first we will select the base plane 1, which will keep as a splitting tool. Okay. And then next we will select the right portion of the revolve feature which you want to delete the solid body. Okay, that's it. Now we will change the direction of the red arrow of split on here. Click OK. Now see the result. My one portion is removed on here. Okay, that's it. In the same way, we will remove the opposite portion of this feature in the following way by using the split command. Now see, close the visibility of these work planes. Okay, it looks great. Now we will make a new work plane at an offset distance value 1.811 inches from the front face of the frame and start the sketch over it. First of all, we will create a circle from this center point and its diameter will keep 0.626 inches. And draw a small circle with the given dimensions on here. Okay, finish the sketch. Activate the extrude command and extrude this sketch region 0.5 inches rear side from this work plane. Click OK. Now select this sketch and choose the share sketch option. Now we will create a hole by selecting this small circle with the help of extrude command. The hole depth value will keep 0.25 inches. Click OK. Open the visibility of XZ plane from the browser bar. Activate the Look at Plane option and select this plane to rotate the model in this position. And start the sketch over this plane. Now we will activate the Slice Graphics command from here and take the project entire model by activating the Project Cut Edges command. Take the project of the XY plane, click Done. Now we will draw a horizontal line like this and apply the coincident constraint between these 2 points. Okay, alright. Now we will fix the dimension between these 2 lines. It will keep 2.71 inches. Okay, that's it. Convert this line into construction geometry. Now create a rectangle on here and fix the coincident relation between the midpoint of the rectangle line and center line. Okay, alright. Now fix the width of the rectangle will keep 0.563 inches. And height will keep 0.2815 inches. Now we will create a line from the rectangle line. 0.1565 inches. Okay, alright. And apply the dimension over this line. Okay, its dimension will keep 1 inches. Okay. Now we create another line from this endpoint to connect it. Now we will convert these 2 lines into construction geometry. Draw a new line over the construction line. Now we will draw some more lines with the given dimensions over the opposite side of the sketch profile, something like this. Okay, that's it. Now my sketch is complete on here, so we will activate the Revolve tool from here and select this sketch region in the design window. Now select the center line for the axis of the revolution and click OK. Now see, save the PAR file. Now we will start the new sketch over the XY plane and take the project of the entire model like this. Choose the front view by selecting the view cube. Take the project of x-axis. Now create a rectangle on here. And fix the coincident constraint on over it. Its height will keep 0.5 inches. Revolve this sketch region like this. Choose New Solid option and click OK. Okay, alright. And now we will open the visibility of the previous work planes. Activate the split command. And now we will choose the trim solid option on here. Select the first plane. Then next we will select the right portion of the revolve feature. Select the reverse side button on here and click OK. Now see the result. Right portion of the revolve feature has been removed by using this tool. Okay, that's it. In the same manner, we will remove the left portion of this feature like this. If you want to create multiple bodies in your single part file, it is a very best example of utilizing this method. Okay, alright. Now we will start the new sketch over the XY plane and take the project of the entire model like this. Now we will draw two vertical lines over the projected line. and fix the dimension 0.375 inches between these two lines. Convert the lines into construction geometry. Okay, alright. Now create a 3-point arc on here. Its radius will keep 0.137 inches. In the same manner, create one more arc like this over the opposite side of the sketch. Its radius will keep 0.142 inches. Okay, alright. Now activate the revolve command and revolve the sketch like this. Okay, that's it. And afterwards, we will remove the left and right portion of this revolve feature by using the split tool in the following way. Okay, alright, it is looking very fine. Now we will select the XY plane, sketch, and take the project entire model like this. Now we will create two vertical lines on here over the both sides of this circular edge. Now we will create two arcs like this to connect the sketch profile. Create another revolve feature by selecting the sketch region. In the same manner, we will be splitting left and right portions of this revolve feature. Okay, that's it. Now see the result. Now we will create another new sketch over the XY plane, okay, and take the project of the entire solid body. Create a rectangle over the center line and fix the width and height of the rectangle 0.812 and 0.15638 inches. Okay, click done. Alright. Now draw a vertical line from here. Now we will draw some more lines, something like this with the given dimensions on here. Now my sketch is fully constrained, so we will start the Revolve tool and select the sketch, and then next select the center line and click OK. Make sure always new solid button should be activated here before creating the new Revolve feature. Now we will create one more Revolve feature like this so that our inner Revolve feature is connected to the outside frame. And afterwards remove the left and right portions of this feature by using the split command that we had told you previously. Now save the part file. Now we will convert the multiple solid bodies in a single solid body by using the Combine tool. Now we will activate the Combine tool from here and go to the solid bodies folder in the browser bar. First of all, we will select the first solid body which will keep as a base, and then next select the remaining solid bodies on here which will keep as a tool body. Click the apply button. Now see the result. Now save the part file. Finally, drill machine frame has been completed here. I hope you may like this video. In this process, if you want to design multi-body part in a single part file, you can make easily. Close the file. Now we will create another new part file from here. Click OK. Here you must be wondering how my file is already opened in a sketch mode automatically, because I have already given some settings in my file. You do not have to worry. Okay, that's it. Now we will create a vertical line on here and fix the coincident constraint between the midpoint of this line and center line. Its length will keep 0.313 inches. Now we will take the offset inside of this line and fix the coincident constraint over this line like this. The length will keep 0.5 inches. Okay. Now we will activate the Semimetric Constraint tool on here and select this line and select the opposite line. Select the center line. Okay, now see. Now we will fix the dimension between these two lines. It will keep 3.311 inches. Zoom all the sketch profile like this. Now we will draw some more lines in the design window and apply the dimensions on over it. Revolve the sketch profile on here and click OK. Now see the result. Now see, my first revolve feature has been created here. Save the part with the name Spindle. Okay, that's it. Now choose the XY plane sketch and take the project of the entire model like this. Change the sketch color as white. Choose the slice graphics option and choose the front view. Okay. Now create a circle from the end point of the projected sketch. Okay. Its diameter will keep 0.03125 inches. Okay, finish the sketch. Now we will activate the Coil tool from here. At first we will select the circle and then next select the axis. Choose the x-axis from the browser bar. Now see the coil preview is visible here in the design window. Choose the reverse direction button, click OK. Now go to the coil size tab and choose the revolution and height option under the type section. Fix the height value 1.25 inches and set the revolution value 20 and click OK. Now see the result. My realistic thread has been successfully created over the cylindrical face of the spindle. Okay, alright, it looks great. Now we create a new work plane over this face. Now here we will remove this enlarged thread which is more than this front face with the help of split command by selecting this work plane. Okay, now see the result. In the same manner, we will remove the enlarged thread over the opposite side of the part in the following way. Okay, alright, it's looking very fine. Now choose the XZ plane for new sketch. And take the project of the entire model and X-axis. Now create a circle over the center line. And fix the dimension between these 2 points. It will keep 0.57365 inches. Okay, give the diameter over this circle 0.03125 inches. Okay, finish the sketch. Now create a small hole by selecting this circle with the help of extrude command. Choose the symmetric option and click OK. Now see. Now we will change the diameter of this circle. It will keep 0.0625 inches. Okay, alright. Now my spindle is completed here, so we will save and close the part file. Now we will create a new part file. Click OK. Now we will draw a base sketch profile of my model chuck of drill machine with the given dimensions like this. Now my sketch is fully constrained. Now go to the Model tab and activate the Revolve tool. Now select this vertical line and click OK to finish the command. Okay, now see. Now we will rotate the model in isometric view and save the file with its default name part 1. Okay, alright. Now choose the YZ plane to start the new sketch. And take the project of the entire model like this. Create a line from the center line. Its length will keep 0.1875 inches. Now take the offset of this slant line, okay, and fix the coincident constraint between these two endpoints to connect it. Now we will take another offset of this top edge and apply the coincident constraint on over it. Fix the dimension between these lines, it will keep 0.25 inches. Now we will erase the unused extended lines like this by using the trim command. Convert this line into construction geometry. Draw one more line on here to close the sketch profile. Now we will create a hole by selecting the sketch profile with the help of Revolve command. Okay, that's it. Now we will create another hole over this internal face of the model. And the hole diameter will keep 0.375 inches. Okay, alright. Now go to the Inspect tab and activate the section view. Now choose the YZ plane, which will keep as a sectioning plane, and click the Apply button to check the result. Now deactivate the section view from here. Rotate the model in this position. And start the sketch over the back face of the model. Draw a circle from the part center point, okay, and fix the diameter 0.5 inches. Click Done, finish the sketch. Cut this profile by activating the Extrude command. The hole depth value will keep 0.938 inches. Okay, now see. Now we will start the sketch over the YZ plane and take the project of the model like this. Now draw a circle over this endpoint and fix the diameter 0.3125 inches on over it. Now we will fix the driven dimension over this projected line. Okay, finish the sketch. Now we will activate the Coil tool from here. At first, we will select this circle and then next select the y-axis from the browser bar. Choose the cut button from here and click OK. Now go to the coil size tab and choose the revolution and height option. Fix the height value. We will select this driven dimension in the graphics area that we had given previously and set the revolution value 60 and click OK. Now see the result. My realistic thread has been successfully created over the internal hole of the spindle. Okay, alright, it looks great. Now select this outer cylindrical surface of the part and change the color of this face as metal steel nerd. Okay, that's it. It is looking very nice. Now my chuck of drill machine is completed here, so we will close the part file. Now we will create a new part file, click OK. Now create a circle from the part origin and its dia will keep 0.5 inches. Now we will draw two lines in the opposite direction from the center line of the circle like this. Now we will fix the semimetric relation between these two lines. And fix the angular dimension between both the lines. It will keep 120 degrees. Okay, that's it. Finish the sketch. Rotate the model in isometric view. Open the visibility of XY plane. Now we will start the 2D sketch command and take a new plane at an offset distance value 0.5 inches from the XY plane and click OK. Now we create a small circle from the center point. And take the project of these two backlines convert the entire sketches into construction geometry. Now we will draw two lines over the construction line and create an arc between these two lines to connect it. Okay, alright, finish the sketch. Now we will activate the Loft tool from here. In the Loft dialog box, first of all, we will select the back and top sketch regions one by one in the graphics area that will be called sections. Okay, that's it. Click OK. Now see the result. It looks great. Now close the visibility of these two work planes and open the visibility of Z-axis. Save the part file with the name part 2. Okay, that's it. Close the part file. Now we will create a new part file and click OK. Now we will create a rectangle over the horizontal construction line and apply a coincident constraint over the rectangle to fix it. Set the width of the rectangle 0.15625 inches. Fix another dimension on here, it will keep as the same. Now we will fix the height of the rectangle 0.63410 inches. Create a vertical line 1.1875 inches away from this rectangle. Okay, alright. Fix another dimension on here, it will keep 0.125 inches. Now we will create some more line in the design window with the given dimensions like this. Now my sketch is fully constrained, so we will start the Revolve tool. It will automatically select the sketch region. Now choose the center construction line for axis of the revolution and click OK. Now see, it looks great. Now we will save this part file. Name it as part 7. Click save. OK. Now rotate the model in this position. Alright, click done. Now we will activate the sketch tool and start the sketch at an offset distance value 0.125 inches from this face and take the project of the YZ plane and XY plane. Okay, alright. Now we will choose the bottom view by selecting the view cube. Okay. Now we will create two circles over this vertical line. Okay. Now we will apply the dimension between these 2 points. It will keep 1.1563 inches. Okay, alright. Now we will fix the outer circle diameter. Its value will keep 0.4375 inches. Okay, and fix the internal circle diameter. It will keep 0.19 inches. Okay, that's it. Finish the sketch. Now choose isometric view. Now we will activate the extrude command. Okay, and select this sketch region. Okay, now we will select the two next option and click OK. Now see, my extrude feature is properly touched over the cylindrical surface of the part by selecting this option. Okay, alright, it is looking very fine. Now we will activate the thread command from here. Hover the pointer over it, and now you can see, observe the tool tip of this tool, that how it works. Okay, that's it. Now we will select the hole and go to the specifications tab. Do not change the default settings of thread tool and click OK. Now see the result. Save the part file. Now we will create a new sketch over this face. Rotate the model. Create a circle from the center point, and its diameter will keep 2.3392 inches. Okay, alright, click done. Now we will activate the geometry text from here. Write the text over this circle in the following way. Write the text box in the text box like this. Now we will change the text font, okay? And we will change some settings of the text so that my text is properly placed over this circle. Now we will change the text color from here as white. Click OK. Now see, finish the sketch. Now we will activate the emboss tool from here and select the text. Now choose the engrave from face option. Select the reverse direction button. Fix the depth value 0.0625 inches. Click OK. And change the color of emboss feature from here. Click OK. Now see. Now we will change the part color as orange medium. Click OK. Now my part is looking very good. Now we will go in the base sketch from the browser bar and change this dimension. It will keep 0.1565 inches. Okay, finish the sketch. Save the part file and close it. Now we will create another new part file and click OK. Draw a rectangle over this construction line and fix the coincident constraint over it so that it is placed in the center part origin. Set the width and height of the rectangle will keep 3.5 by 0.375 inches. Okay, alright. Zoom all the sketch. Now we will draw 3 small circles on here like this. And fix the distance between these 2 points. Okay, it will keep 0.319 inches. Its diameter will keep 0.25 inches. Okay. Apply another dimension on here. It will keep 1.475 inches. This circle diameter will keep 0.19 inches. Okay, that's it. And select this line and this center point of the circle. Its dimension will keep 3.25 inches. Okay. Its circle diameter also will keep 0.19 inches. Okay, finish the sketch. Rotate the model in isometric view. Now activate the extrude command and select the sketch region. Extrude this sketch profile 0.063 inches. Click OK. Now my plate is created here. Now we will start the new sketch over this face and take the project of this circular edge. Now create a circle over this center point and its diameter will keep 0.359 inches. Okay, finish the sketch. Now we will extrude this sketch region 0.06263 inches. Click OK. Now we will change the material of this part as metal AL polished. Okay, that's it. Now my model is looking very shining. And save the part, name it as part 4. Now we will go in the base sketch of this part from the browser bar and change this dimension. It will keep 1.4753 inches. Okay, finish the sketch. Now save the part and close it. Now we will create another new part file and click OK. Draw a rectangle over this construction line. And fix the coincident constraint over it so that it is placed in the center part origin. The height and width of the rectangle will keep 0.438 by 0.219 inches. Now we will take the offset inside of this line and fix the dimension between these two lines. It will keep 0.126 inches. Convert this vertical line into construction geometry. Now we will draw some more lines in the design window, something like this with the given dimensions. Now create a point on here and apply the dimension to fix it. Now draw an arc between these 2 points and its radius will keep 0.62 inches. Now we will take the offset outside from the previous line. This line dimension will keep 0.375 inches. Draw one more arc on here to connect the sketch. Fix the dimension between these two lines. It will keep 1.344 inches. Its radius will keep 0.623 inches. Now draw a horizontal line to close the sketch profile. My sketch is fully constrained, so we will finish the sketch. Now we will start the Revolve tool from here and select the center axis to create a revolve feature. Okay, that's it. Now we will change the color of my handle as wood ash. Now see, it looks great. Save the part file and close it. Now we will create a new inch part file. Okay. Now create two circles from the center point. Fix the diameter of the outer circle 0.5 inches. And others will keep 0.19 inches. Okay, finish the sketch. Now we will extrude this sketch region 0.25 inches in this direction and click OK. Now we will activate the shell tool. Okay, hover the pointer over it and now you can observe the tool tip of this tool, that how it works. Okay, that's it. Select the front face of this part and fix the wall thickness value 0.031 inches and click OK. Now see the result. Now we will change the material of this part as metal AL polished. Okay, that's it. Now my part is looking very shining. Save the part file with the name part 3. Okay, alright. Close the file. Now we will design a washer of my drill machine in the following way. And start the sketch on here. Create the two circles over the part origin and fix the diameter of the outer circle 0.4375 inches. Okay, set the diameter of the inner circle 0.19 inches. Finish the sketch. Now activate the extrude command and extrude this sketch region 0.023 inches. Okay, that's it. Save the part with the name washer. Okay, alright. Close the file. Now we will create another new inch part file from here. Okay. Now we draw a rectangle over this construction line and set the dimension on here to fix it. Now create a line on here its dimension will keep 0.032 inches. Now create a point on here. Create an arc between these 2 points and set the radius 1.095 inches. Now we draw another arc on here and its radius will keep 0.683 inches. Now we will create a line over the end of the sketch like this. Activate the Revolve tool, select this line for axis for revolution and click OK. Now see. Now we will create a hole over the front face of the handle like this with the help of extrude command. Its diameter 0.313 inches and depth will keep 1 inch. Okay, alright. Now we will change the color of my handle as wood ash. Now see, it looks great. Save the part file with the name part 6 and close it. Now we will create a new part file from here. Okay. Now create a circle from the center point and its diameter will keep 0.625 inches. Now we will activate the extrude command, rotate the model in isometric view and extrude the sketch 0.281 inches. Click OK. Now we will create a shell feature over the front face of the model and set the wall thickness value 0.03125 inches. Now we will create a hole over the back face of this part like this. Okay, now see. Now we will change the color of this part and save the part with the name part 9. And close the file. Now we will create a new inch part file from here. Okay. Now we draw a horizontal line over this construction line and its length will keep 4.666 inches. Okay, alright. Now we will draw a vertical line from the part origin and its dimension will keep 0.344 inches. Now we will draw two more lines in the design window, something like this with the given dimensions. Now we will create 4 points on here, and afterwards we will give the dimensions on over it to fix them. Okay, that's it. Now my points are fully constrained on here. And now we will activate the spline tool from here. Then next we will select this point, this point, this point, and this point. Okay, that's it. Now see the result. Now my spline has been successfully created on over these points. Okay, start the Revolve Tool. It will automatically select the sketch region in the design window. Select this horizontal line for axis for the revolution and click OK. Now see. Now my large handle has been created on here. Now change the color of handle as wood ash. Now see, it looks great. Now we will create a hole over the front face of the handle like this with the help of extrude command. Its diameter 0.313 inches and depth will keep 1 inch. Okay, alright. Now save the part file and close it. Now we will create a cover of this large wood handle that we had just created. Okay, that's it. Save the part with the name part 12. Okay, alright, close the file. Finally, all the components of drill machine model are finished here. So we will now create a new inch assembly file in Autodesk Inventor. Click OK to create a new assembly file on here. Now my assembly design window is visible on your screen. Now choose an isometric view by selecting the view cube. First of all, we will activate the place component command from the component panel. Okay. Now we will select the drill machine frame part that we had created first. Okay, alright, and place the frame in this assembly. This time my assembly is fully constrained. Here no need to give any mates over this part because this part is grounded part. When a first part is placed in Inventor assembly, it will automatically place as a grounded component. Okay, alright. Now we will rotate the assembly in this position by selecting the view cube. Now save this assembly with the name drill machine. Click save. Okay, that's it. Now we will insert the part 11 file in this assembly by activating the place component command. Okay. And insert the part file 12 on here. Now activate the rotate component tool from here. Select the part 12 file and rotate the model in this position. Click done. Now we will activate the constraint command from the positions panel. Then next select the whole axis of the handle and the whole axis of the second part and apply the axis mate between them. Okay, alright. Now drag the handle from here. Now we will fix the mate constraint between this internal face of the cap and outer face of the handle. Rotate the handle in this position. Now we will go to the Inspect tab and activate the Analyze Interference command. At first, we will select the handle and then next cap and click OK to check the result. The message is shown on here. There were no interference detected. Now we will fix the mate constraint between the whole axis of the handle and the center axis of the frame. Okay, that's it. Now select this one and this one. Apply another mate constraint between them. Okay, alright. Now open the visibility of XY planes of the assembly and part 11 from the browser bar and part 11 file from the browser bar. And fix the mate constraint between both work planes so that the handle of drill machine cannot rotate. In the same manner, we will fix the cap of the handle by using this mate. Now close the visibility of these work planes. The handle is fully constrained on here. Save the assembly. And now we will check the interference between the frame and handle. Now see the result. Now we will insert the spindle component in this assembly. Okay, edit the spindle part from here and create an axis over this hole. Okay, return back to the assembly. Now we will apply the mate constraint between the axis of spindle and frame. Okay, alright. Rotate the spindle in this position. Drag the spindle on here. Okay. Now select this internal hole face of the frame and select the back face of the spindle and apply mate constraint between them. Now see the result. Spindle is properly placed over the drill machine frame. Okay, that's it. Now we will check the interference between both the part files. Okay, alright. Now we will place the part 1 file in this assembly. Now select this one and apply a mate constraint between them. Okay, alright, now see the result. Now we will select the front face of the spindle. Okay, now rotate the assembly in this position. And select this internal face of the part 1 file and apply the mate constraint between them. Now drag the part file from here. Now see, my part 1 is rotating. It means that my mates are properly working on here. Okay. Now we will open the visibility of YZ plane of part 1 file. Okay. Now we will open the visibility of XY plane of the spindle. Okay. Activate the constraint command, select this plane and apply mate constraint between them. Okay. Close the visibility of these work planes. Now we will drag the chuck of drill machine. Okay, now see my chuck and spindle are rotating simultaneously here. Okay, alright. Now we will place the 3 copies of part 2 files like this in this assembly. Okay. Activate the constraint command, select the center axis of this frame. Okay, and select the Z axis of this part file and apply mate constraint between them. Okay, now see. Drag the part 2 file from here. Now rotate the model in this position. Now we will apply a mate constraint between these two vertical axes of this part like this. Then select these two edges to give another mate constraint. Okay. In the same way, we will fix this part in the following way. Okay, now see the result. Now we will fix the mate constraint between the whole face of part 1 and the back face of the part 2. Now we will give the mate constraint between the YZ plane of part 1 and XZ plane of part 2 so that part 2 file becomes rotate with the chuck of drill machine. Okay, now see. Now we will place the pinion 1 file in this assembly. And change its name from here like this. Now open the visibility of Z-axis of this part and open tooth point of this pinion. Okay, now we will apply a mate constraint between the center axis of the frame and the Z-axis of the pinion. Rotate the pinion in this position. Now we will place the pinion 2 file in this assembly. And change its name from here like this. In the same manner, we will fix the same constraint on over this pinion that we had given just before. Now drag the second pinion like this. Now open the visibility of work axis 12 of this part. Now we will give the mate constraint between these two axes of these parts on here. Click apply button to fix it. Now we will place a rivet of the pinion in this assembly. And fix the rivet over the whole of this pinion by activating the insert mate command. Okay, that's it. Now we will check the interference between the pinion and frame. Now see the result. Now we will place the part 7 file in this assembly. And place the bevel gear part file in this assembly. Now we will fix the axis mate between these two parts like this. Okay, now see. Select this face and this face and fix the mate constraint between them. Okay, alright. Now we will give the mate constraint between the YZ plane of part 7 and XZ plane of bevel gear. Okay, now see. Close the visibility of this workplace. Now rotate the assembly in this position and save the assembly. Now we will select this whole axis of part 7 and the frame axis and fix the mate constraint between them. Now we will select the two pinions and bevel gear in the design window and choose the isolate option in the graphics area. Now you can see here only 3 components are visible here in the design window by selecting this option. Now we will open the visibility of intersection point of the pinion 2. Drag the pinion, now see. In the same manner, we will open the visibility of intersection point of pinion 1 and bevel gear files. Now you can see here 3 intersection points are visible here in the design window. Fix the mid constraint between these 2 intersection points on here. And fix another mid between this point and bevel gear point. Okay, alright. Now drag the part files on here to check the result. Okay, that's it. Now save the file. Now we will activate the Constraint tool from here and go to the Motion tab in the Constraint dialog box. First of all, we will select the internal cylindrical surface of the bevel gear, and then next select the outer cylindrical surface of the pinion 2. Now you can see here the 2 rotational red arrow symbols are visible in the design window. Okay, alright. And enter the ratio value 15 by 56. Okay. On here, we have selected the forward button under the solution area so that the bevel gear and pinion simultaneously can be rotated in the same direction, and click OK to fix the rotational motion between the bevel gear and pinion 2. In the same manner, we will give another rotational motion between the bevel gear and pinion 1. Okay, that's it. Now drag the part files on here to check the result. Now see, both pinions and bevel gear are simultaneously rotating in the design window. It means that my rotational motion constraints are perfectly working on over these components. Okay, that's it. Now choose Undo Isolate option in the design window to full viewing for all the assembly components. Now we will rotate drill machine assembly in this position. Now we will drag the drill machine assembly like this to see the result. Okay, it's working very fine. Now we will place the handle in this assembly. Drag the handle something like this. Now we will fix the axis made between this hole and the machine frame like this. And select this one and this one and apply another mate constraint between them and click OK. Alright. Now we will check the interference between these 2 components. Now see. Now we will place the washer in this assembly. and fix the washer over the part 7 file like this. Now we will fix the mate constraint between the whole axis of the handle and washer. Okay. Place the screw in this assembly. And fix the screw over the whole of the handle by using insert mate command. Okay, now see. Now we will place the small handle and its cap in this assembly. And fix the axis mate between cap and handle. And select this one and apply another mate constraint between them. Okay, alright. Now drag the handle from here and rotate the handle in this position. And fix the mate constraint between the front face of the handle and back face of the cap. Okay, now see the result. Now we will place the long screw and its nut in this assembly. And fix the screw over the whole of the handle. Now we will fix the nut over this screw in the following way. Now we will place another small handle and its cap in this assembly. And fix the axis mate between the whole of these two components. Okay, alright. Drag the cap from here and select the internal face of the cap and this face of the handle. Apply mate constraint between them. Now we will fix the axis mate between this hole and the machine frame like this. Rotate the assembly in this position and select this face of the frame and the back face of the handle and apply another mate constraint between them. Okay, now see. Now we will fix the mate constraint between XZ plane of the part 6 and YZ plane of the main assembly with the help of angle mate so that the handle of the drill machine cannot be rotated. In the same manner, we will also fix its gap on here. Okay, that's it. Now close the visibility of these work planes. Now save the drill machine assembly. Finally, my drill machine assembly has been completed on here in Autodesk Inventor. I hope you will enjoy this video. If you may like this video, please like and subscribe to our YouTube channel. Please share this video with your friends and colleagues. Okay friends, goodbye.